All right. So here to talk about cross-platform packaging and building apps for cross-platform in Kivy is one of the Kivy Core Developers. So an applause for Mirko and welcome.
Thank you. Thank you. So we are here today to talk about Kivy, the open source Python app development framework. With Kivy, you can build and distribute beautiful Python cross-platform great apps with ease. But let's start with something super easy. Who I am? I'm Mirko. I'm based in Monza, Italy. And as my PyCon bed 2022 badge says, from Monday to Friday, I'm full stack Pythonista. And on Saturday and Sundays, and also evenings, I'm a core Kivy developer. But I'm not alone in Kivy. We are a group of 8 core developers at the moment. We are quite widespread all around the world. And we also have a last addition to the team, which is Julian Ho, which is part of the Kivy triage team, a new team we created to easily triage issues. And we also have all these amazing core contributors along all our repositories at Kivy organization. And we also have 195 sponsors and supporters via Open Collective. But I guess we can consider this commit as the Kivy board day. Well, 13 years ago. But only 13 years ago? Well, Kivy is actually a reboot of PyMT, Python Multitouch, which has been created in 2007, 16 years ago, by Mathieu, which is the creator of Kivy. And Kivy still shares chunks of code of PyMT. So Kivy is made for today and tomorrow. Novel input methods such as multitouch have become increasingly important. We created Kivy from scratch specifically for this kind of interaction. Well, even if that statement has been added quite a long time ago to our docs, still look fresh. Even the most important things may have changed meanwhile, as the framework is evolved and is evolving with the tech. Okay, Kivy looks like a robust, long-maintained project, but why we should choose Kivy for app development, and how I can persuade my coworkers or myself to adopt non-Pythonic ways to develop mobile DEX or GUI apps. Well, Kivy is great for freelancers, small teams, and big corps. Why? Because Kivy is cross-platform. So with Kivy, you only have to write once, and then you can deploy anywhere where is iOS, Android, macOS, Windows, and Linux, so almost everywhere. So that means less code to maintain. And also Kivy is fast, because time-critical functionalities are implemented inside them, is GPU accelerated when it makes sense, and also implements intelligent algorithms to minimize cost operations. And Kivy is also business-friendly, because unlike some, we could call them competitors, Kivy is a leader under MIT license, and is 100% free to use, and is professionally developed, big and maintained. And companies like the one I work for and individuals are using Kivy for their projects every day. So Kivy is completely free with no hidden cost, but please just consider making a source code contributions. Are we at a PyCon event? Are we Pythonistas? If not, why you're here? Did you get yourself lost? And CobbleCon is just down in the basement where a gigantic mainframe is waiting for you. So if we are all Pythonistas, Kivy is here for all of us. Why? Because Kivy makes Pythonistas happier. How? Well, as Pythonistas, we are probably quite open-minded, so we are probably good to switch to another language to develop desktop mobile GUI apps. But are we really happy to switch to another language? I don't think so. And an happier software developer is less prone to generate bugs. Is that true? I don't know, but I feel more comfortable writing Python code. Kivy is just the visible part of the iceberg. While I was writing the first version of these slides, I need to explain to people how the Kivy ecosystem is huge. And so I thought, hey, Kivy is the part I use to create the UI is just the visible part. Everything else stays on the bottom. So let's have a guided tour to the Kivy ecosystem, and this is you. So why Kivy is an ecosystem? Well, let's consider 2 major parts. The part which I call being cross-platform, which is PyGenius, PyHubGest, and Player, and on the other side, we have the packaging part. So Python 400, KiwiOS, and Bulldozer. And this is just an overview of the And we also have other small parts of the Kivy ecosystem, but these are the most important. So let's talk about Pygenius. Pygenius is a Python module to access Java classes as Python classes using the Java native interface. Well, why we need that? I want to write Python code. Well, sometimes you have to interact with Java API, for example, on Android. So with Pygenius, you can access Android APIs and third-party Android libraries from Python. And this is super important to integrate, for example, with Bluetooth Low Energy. If you need to access Bluetooth Low Energy on Android, you need to use Pygenius. And this is also useful to access Java classes on your desktop environment, because you can also, maybe you already have some Java code, and you want to interact with that Java code, and you could do that by using Pygenius. So if you look at the example, what we have here, we are just importing AutoClass from Genius and AutoClass helper. And with the AutoClass helper, we are loading the necessary classes, and then we are using these classes. And when we are showing the toast message, this is the rest on my Android phone, actually. So the native toast message. And like Pygenius, we also have PyObjects. PyObjects is a Python module for accessing Objective-C classes as Python classes using the Objective-C time reflection. So, like Pygenius, but for macOS and iOS, so we can access Android native, native and third-party APIs on both iOS and macOS from Python. So, again, as an example, if you want to access Bluetooth Low Energy, we can do that by using PyObjects. And yeah. As the example show, I'm just loading, again, the AutoClass helper, then we are loading the NSR class via the AutoClass helper, and then we are using it to show this model on my Mac. And then we have Plier. Plier is a platform-independent API that uses features commonly found on various platforms, not only mobile ones, in Python. So what we are doing here in Plier is just import Plier, and then plier.tts, which is text-to-speech, .speak hello world. If I run the script on my Mac, it actually says hello world and loud voice without no access setup, with no access dependencies needed. And like text-to-speech, we have access to accelerometer, audio encoder, and barometer, and so on. Obviously, it leverages Pygenius and PyObjects when needed, but we done the work for you. So this is the Pythonic alternative to access platform-specific features. So we are now ready to deploy a fully featured app. Well, we still need to package it. These two friends are here to help, Python for Android and Kivy US. With both, you can create your own Python distribution with native models and dependencies, and bundle it into an artifact that can run on your device along with your own code and assets. So those are just copying my dependencies and coding on an artifact that can run on Android or iOS. Well, unfortunately, not that easy, at least for us. So let's have a whiteboard session. Why is it not easy to package on Python mobile app? Usually here you can win a Kivy shirt, but my baggage allowance don't permit that. But I can ship one to your home. So why is it not easy to package my Python mobile app? Quickly? No one? Okay. So we need to package a Python interpreter that's able to run on Android or iOS, and we need to start the Python interpreter. Non-plain Python packages are not available on PyP for Android or iOS. Oh. And on iOS, at least for our implementation, we are required to statically link everything on the main executable, and not everything is available on iOS and Android. Like subprocess, for example. You can't use subprocess on iOS. And data scientists, how many are there? Oh, great, only one. Love libraries based on Python. I don't know why. And no, Android doesn't have apt-get, and no, iOS doesn't have BU. So you can just BU install something on your iOS device, and many, many more. So how we manage to fix it? And yeah, we can do better, and how the whole Python community can help, or is working on it. Kivy US and Python for Android, how they work, the example approach. So let's take an example, an app which takes dependencies. Python 3, which is our lovely Python interpreter, and needs to be cross-compiled and patched to run the target platform. Same applies for its sub-dependencies, like OpenSSL, libFFI, and SQLite 3. And a recipe will take care of it. Oh, this is a recipe. We're going to eat pizza today. Then we have libx264, and libx264 also needs to be cross-compiled. And we need, again, a recipe. And then we have Kivy, which is a Python package, but have compiler components and needs to be cross-compiled. And Raspberry will take care of it. And then we have NumPy. NumPy, again, is a Python package, but have compiler components, so needs to be cross-compiled. And again, Raspberry will take care of it. And then finally, we have PyTZ and Babel, which just Python package and not plain Python packages, so we are just pip installing them. So 90% is in complexity is in Raspberry, where 90% is just a random number in the 80 or 100% range. So what are recipes? Recipes are a set of instructions to simplify the patching and cross-compilation processes for various types of packages. You don't need to worry about that, because unless you want to create a new recipe and submit a PR, obviously, because the set of already available recipes is quite limited, but enough for the average app. This is the result. We are going to have our Android iOS app with the Bootstrap, the Python 3, which is able to run on the target device, and the Python packages, both the cross-compiled ones and the plain Python packages, then the libraries like OpenSSL or SDL2, which are also cross-compiled, and finally, your app with your app code and assets. Then we have Bulldozer. Bulldozer is a tool for simplify packaging. And let's talk about key points of Bulldozer. Your app, your rules. Oh yeah, my app, my rules. So why? Because with one single Bulldozer spec file in your app directory, which describes your application requirement, we are able to build your app. And one-stop packaging, because with Bulldozer, and Bulldozer creates pages for Android, iOS, and macOS with the same Bulldozer.spec file, so you don't have to write another specification file. Let's talk about the usage. Bulldozer init. Easy. So what it means? It means, hey, Bulldozer, can you please create a new Bulldozer.spec file that later I'm editing it? Yeah, for sure. And Bulldozer and the debug deploy run. What that means hey, Bulldozer, can you please build an Android artifact in debug mode? Deploy and the device and run it. Easy and effective. So let's have a small brief about the current status of Bulldozer. On Android, fully supported, and use Python for under the hood. On macOS, we use a Kivy.app, a pre-built artifact under the hood. And on iOS, is partially supported, but uses Kivy iOS under the hood. Partially supported means that doesn't support all the features that Kivy iOS have, but it's still fine. And on Windows and Linux, the alternative is Spy installer, but PRs are welcome. So finally, the visible part of the iceberg. So let's have a brief introduction to the visible part of the iceberg, Kivy. Kivy abstracts basic tasks such as opening a window, displaying images, displaying text, playing audio, and so on. This makes the API both easy to use and easy to extend. And most importantly, it allows us to use specific providers for the respective scenario in which your app is being run. What it means you don't have to worry about that. Because on every platform, Kivy chooses the best core provider implementation to use. Kivy design language. Kivy language allows the developer to create the widget tree in a declarative way, and to bind widgets properties to each other or to callbacks in a natural manner. So yeah, you can create Kivy widgets via Python code, but unless you know what you're doing, please don't do that. Use the Kivy language. Kivy language is declarative, is more easy to read, and easy to maintain. Because it allows for very fast prototypes and major changes to your UI, and also facilitates separating the logic of your application and its user interface, so you don't have to be like them. You don't have to be like PHP, or you don't have to be like someone 4 weeks ago at the conference. Why you're doing that? So keep your logic and your UI separate, please. Properties. Kivy properties are not the same as Python properties. At Kivy, we have numeric property, string property, list property, and so on. These properties implement the observer pattern, and to use them, you have to declare them at class level. Kivy properties help you to easily manipulate widgets defined in Kivy language, ultimately observe any changes and act accordingly. And also check and validate values. You can also use them to optimize memory management. So what we are doing here in the example is just to declare the click count numeric property, which defaults to 0, and then we are creating a method which increments this property, and then onClick count, what is onClick count? Well, each property, by default, provides an on_property name event that is called whenever the property state value changes. So when this property changes, this callback is called automatically. So every time we are incrementing the click count property, automatically onClick count gets called and says click count clock. Well, you will probably find yourself scheduling something in the future once or repeatedly at specific intervals. Kivy clock is here to help. If you're using Kivy clock, by Kivy clock.schedule interval, my callback 0.5 means, hey, can you schedule this callback to be called every 0.5 seconds? And then we have schedule once, my callback in 5 seconds, so only once. Or schedule once, my callback, it means, please schedule this callback to be called as soon as possible, usually the next frame. And then, yeah, you can also create a trigger for later. A Kivy widget has 2 default types of events. Widget-defined events, as an example events fired when the button is released or pressed, or like, yeah, these ones are 2 examples of widget-defined events. And then we have the property event. If your widget changes position or size, an event is fired, as seen in Kivy properties before. So onCurrent status is a property event. Canvas. Well, we need to display something on the display, right? So Canvas is here for that. Each widget has canvas, a key place to do one. The canvas is a group of doing instructions that should be executed whenever there's a change to the widget graphical representation. Canvas before and canvas after groups can be used to separate instructions based on when you want them to be executed. You can add instructions either for the Python code or from the Kivy file, but please use the Kivy file. So how we can do that? How we can have a red rounded rectangle with a label on top of it, and on top of it, again, a blue ellipse. Well, we are using a box layout, which is empty, and then we are placing with canvas before a red rounded rectangle. We are setting the red color, and then we are creating a rounded rectangle. Then we are placing a label on top of it, which says hi, and we are setting the color to white. And on top of that, we are placing an ellipse. So we are setting the color to blue with half the alpha value, so we can see on the layer, previous layer, and then we are creating an ellipse. Yeah, you can add instructions either from the Python code or from the Kivy file. But if you done them from the Kivy file, the advantage is they are automatically updated when any Kivy property changes. So please, again, use the Kivy files. Kivy is a UI framework, so have built-in UI components. All these components are just for layouting, and then we have accordion, action bar, bubble, button, camera, checkbox, code input, color picker, and so on. All these widgets make your UI possible. And Kivy also has a community material garden, but it's not the kind of garden you need to water, but it's still full of flowers. Kivy Garden is an organization for software for developers of Kivy widgets, add-on and related software. Some examples are ZBarCam, MapView, and Graph. Freedom. Why freedom? Because Kivy provides the base. Our community garden full of flowers, but you can even do more. Because even if Kivy comes with its own set of icons in its UI theme, there's no need to stick on it. You can create new widgets and customize existing ones. And spoiler, at least for me, is easier to write than some CSS3. This one is an app that they maintain and have a lot of custom widgets, like the one for the rolling shutter. This one is fully custom, obviously doesn't exist in Kivy library. And this one instead is an app from one of our sponsors that tracks the car on the racetrack and shows the data in real time. And these are all custom widgets. We've previously seen how packaging can be can be challenging, so it's tip and tricks time. I've created this slide that you can find later that can help you to write a cross-platform app, and not only a Kivy cross-platform app. Please follow all these steps. And now, do you remember the slide? is working on it. What is this number? In Italy, it's a tax form name, but that's not the case. 730 is PEP 730 adding iOS support and platform. I started crying of joy when I said it. And like iOS, it's still a draft, but they're working on it, and there's a high chance to having that in Python version 3.13. That means less issues when packaging these things via Python for Android and KVOS. Because we're probably going to have packages for iOS on PyP. Oh, wonderful. So, some fresh news. Kivy 2.3.0 status, release either is December 2023. Unfortunately, we are late for Python 3.12, but we are waiting for dependencies to start the release process. And we moved some of the features to Kivy Next. Why Next? Because we probably need to break the API, so we need to probably go into Kivy 3.0.0, because we are going to have a brand new text import core provider, which is going to support all the things that usually your Android or iOS keyboard support. And we also going to have revisit the camera and file access. So let's talk about the future. We need to improve the documentation and guides, or if you are a documentation master, please reach out to us, we need you. And we need to involve more the Python community, more the community meetups and live stream or conferences like this one. And you also need to improve the support for non-Latin languages. So if you are a native non-Latin languages reader, please also reach out to us to help the development. And together is better. We need to involve the whole Python community making aware of mobile platforms. But something is moving with PEP 730. So thank you. And if you want to talk about Kivy, feel free to ping me in real life to start chatting.
Questions?
Do we have any questions?
Hi. Talking about like specialized tools like Android Studio, for example, or Xcode, it's when you're developing a mobile application, it's important to see the results of your work as soon as possible. Like they have, for example, those emulators that allow you to view whatever you're doing almost in real time on the computer. How can you do something like that using the Kivy?
Well, actually, we have a project which is called Kaki, and we are probably going to work on this tool or having another one soon. With this tool, basically, you can have an app that runs on your desktop machine, which is actually the same of the one you are going to have on iOS or Android, unless you are using some Android or iOS specific features via PyObjects or PyGenius, and that automatically reloads every time a change is made in the Kivy file. So that can help during the development. Clearly, if you have to test out the Bluetooth Low Energy, for example, you need to be on the real device. So also the simulator in Xcode is not enough. But we use Xcode for the later step when preparing the app for the development, and we are also using Xcode to debug the app if needed.
So I have not used Kivy, so I might be asking some stupid question now, but usually when using similar libraries, I've experienced that it's very hard to get a kind of native feel on mobile platforms. It works good for maybe games and stuff, but if you want something to feel like a native app, that's usually very hard to achieve not using the native languages. Is this a problem with Kivy, or?
We have, there are libraries from out of the wild, from other developers that can help to have a native look on iOS and on Android, like Material Design or it's called Cupertino style. But at least this app works both for iOS and Android is not probably a game, but have the same UI and the same aspect along the two devices. So yeah, sometimes maybe an issue, but if I look at the most important apps like the food delivery apps, they're quite the same on Android or on iOS. But yeah, there are also libraries to help that.
Okay, thank you.
Did we have another question? Yes. Okay, last question then. Because we're running into lunch.
Thanks for an interesting talk. I have an app which is targeted mostly towards mobile Linux phones, and that's my primary target, but it would also be interesting for me to have it run on Android. So can you say a bit about current Linux support? And you said that Bulldozer doesn't have support for Linux yet. And
yeah, but Bulldozer doesn't have support for Linux yet, but you can package this via Pyinstaller, and then you can run it via your Linux machine. Or you can ask your user to pip install that. You can also create a package for the Python, the Kivy app, and then you can distribute via the PyPI.
All right, thank you so much. And I know there was a few more questions, so just grab him for lunch, which is now, and ask your questions then. Thank you so much, and another round of applause.
Thank you.